Good afternoon, everyone, and thank you for joining me today. My name is Radhika Ravirala. I'm a solutions architect with Amazon Web Services, and it is indeed a pleasure to be talking to you all about managed database services on AWS. I'd like to kick off this session with a quick post-lunch poll. Big hint, this has nothing to do with the menu. So how many of you are currently running a relational database system on AWS? Fantastic, a lot of you. And how many of you are either using or running a NoSQL database on premises or in the cloud? Wow, a good number of you. So thanks for joining me today. And with that, let's get started. So the focus of this presentation really is to delve into why we would want to use managed database services. What are some of the benefits it offers? Also look into some differences between a relational database versus a NoSQL database. And then we'll get into some details about 4 different managed database offerings on the AWS platform. And with each of them, we'll look into their capabilities, the use cases they are best suited for, how some of the customers are using them in their live production environments. And finally, we'll wrap up with some summarization and what your next steps might look like. So let's begin with the fundamental question. Why do we want to use managed databases? What are some of the benefits they can offer to you? If you're currently an application owner or a database owner and host your database on premises, there are a myriad of tasks that you're responsible for. It starts with powering and providing network connectivity to the servers, from racking and stacking, performing regular maintenance on the server, installing the operating system, database, applying patches on them regularly, taking care of backups, high availability, and scalability for your database to meet the growing demands of your application, and finally, the task that you get most credit for, which is application optimization. Now, as you may have noticed, many of these tasks are routine and mundane, and a lot of times you don't even get props for performing any of these unless something really goes wrong. Wouldn't it be nice if you can offload some of these tasks to somebody who is really good at it? That's where EC2 comes into picture. If you host your database on EC2 instances, AWS will relieve you of the infrastructure tasks associated with running your database, while leaving you still responsible for all the database activities and the application optimization. Now, let's take this to a next level. What if you could offload even the administrative tasks and give it to someone else? That's exactly where managed database services come into picture. So if you opt to run your database as a managed service, AWS will take care of all the undifferentiated heavy lifting associated with the infrastructure as well as the common administrative tasks for your database, leaving you to focus on the most important part of your job, which is application optimization and improving your product in general. Now, to quickly summarize what we have seen so far, there are really 3 different options for running your database. You can go through a self-managed route where you're responsible for the hardware, operating system, the database, and all the activities related to it, while still remaining in total control of the entire setup and configuration. You can go with the EC2 route where you're at least relieved of the infrastructure portion, but you're still taking care of backups and replication and high availability for your databases. Or you can opt to go with the fully managed route where infrastructure as well as database tasks are offered as a package, as a service to you, and you can focus on your product. So with that, let's dive into the managed database services available on the platform today. So we have Amazon RDS, which is a service that lets you run relational databases on AWS. We have Amazon DynamoDB, which is a document and key value store. We have a petabyte scale warehousing solution in the form of Amazon Redshift. And finally, we have an in-memory key value store called ElastiCache. Now, with these options come a lot of decisions that you have to make. Should I go with a NoSQL database or a relational database? Which database engine should I use? Should I simply choose a DynamoDB instead of running MongoDB on EC2 instances? These are all the decisions that you have to make when you're thinking about your application. Well, the answer to these questions lies in looking at your application requirements as well as the salient features of these services. Let's take an example. Say you have a new application that you want to build. How do you choose between a NoSQL database and a relational database? So let's look at the characteristics. As you all know, relational databases allow you to define schema. They support complex relationship. They have support for transactions, joins. They focus primarily on data integrity and consistency over scale and availability. Scaling is challenging, but if you require the asset goodness for your application, then relational database it is, that will be well suited for your application. On the other hand, NoSQL database are schemaless. They have a very simple data model. Scaling is super easy, and the focus there is primarily on availability and high performance at any scale. So let's dive into each of these managed database services and see what they have to offer, starting with RDS. So as the name suggests, Amazon RDS is a service that lets you run a relational database engine in the Amazon cloud or AWS. You have 6 different database engines to choose from, and RDS supports multiple versions of each one of them. Today, you can run MySQL, PostgreSQL, SQL Server, Oracle, MariaDB, and Amazon Aurora. With each of these different database engines, RDS takes care of all the provisioning, all the automated backups, failover detection and recovery, and some software updates in the form of minor patching. It offers fast and predictable performance, and as you will see in later slides, it is really simple and fast to scale. What about security, you may ask? If you run your database as an RDS, you can run your database instance in a VPC or a virtual private network, which gives you total network isolation. You can leverage identity and access management service within AWS to control and assign permissions to who gets to access your RDS resources. You can even leverage security groups to control which IP addresses or EC2 instances can actually talk to your database instances. You can further enhance it by using SSL to connect to your databases. And let's not forget that your own database engine has security features, and you can leverage those to control who can log into your databases and so on. Databases have a 25+ years of history, so it is no surprise that they have manifested in every imaginable vertical that you can think of. For example, e-commerce and retail companies use databases not only to support their operations, but also underpin their interactions with customers and suppliers and so on. Websites, gaming companies, even developers who are developing applications as a hobby need a store, a data store to hold their information. They're all leveraging the capabilities of a database to support their business functions. And let's not forget, many businesses use databases as a backend store for their reporting structure. So here is a feature matrix for the 6 different database engines available on AWS today. As you can see, a vast majority of the functions are available or common among all the 6 different engines. The big thing to note here is that from a managed service perspective, you can do a lot with each one of these services. The decision on which service to use or which database engine to use really comes down to the specific functionality that you desire from the database engine, or if you have a specific integration point with any particular database engine. So now you're already familiar with MySQL, PostgreSQL, Oracle, SQL Server, and MariaDB. Let's focus and zoom in a little bit into Aurora because it has pretty big differences compared to the other database engines. So Amazon Aurora is a fast, designed for the cloud, MySQL-compatible database engine that was developed at Amazon. In terms of performance, it is 5 times faster than MySQL on the same hardware. It can scale up to millions of transactions per minute. And in additional testing we conducted using Sysbench benchmarking suite, it delivered over 100K writes per second and 500K reads per second. With Aurora, you really don't have to engineer for high availability. It's already built into the product. Every chunk of data that you write to an Aurora database is replicated 6 ways across 3 availability zones, giving you the data redundancy and availability that is desired of a database. Whenever you do a read or a write, Amazon Aurora performs a quorum. So for a read, it needs a response from at least 3 storage nodes. And for writes, it needs a response from at least 4 out of 6 nodes for it to call that operation successful. And in terms of storage, Aurora storage grows naturally as you consume the storage, and it can grow all the way up to 64 terabytes. And if you have read-intensive applications, you can even launch up to 15 read replicas to support your read-heavy workload. Another challenge that database owners often encounter is sizing your database instance. On premises, if you are trying to launch a database or provision a database, you have a set configuration specification that you have to go through. And once you procure that database on premises, you really cannot do much about it. You cannot change it easily. There are a lot of steps involved. But with RDS, scaling is simple and really fast. You're simply increasing the size of the database instance as it pertains to CPU and memory in the management console. And you can scale up and down these instances to a different class based on your demand. And why do you want to actually resize your database instance? There are a variety of reasons. It could be that you are expecting a surge in traffic for your database, maybe because of an event that you are going to have in the next few weeks. Or maybe your business is seasonal and you want to cut back on your database size and save on costs by scaling down to a smaller database. So all these are good enough reasons for you to modify your database instance and save up. You can also scale the storage with RDS, but keep in mind that you can only add, you cannot take away the storage once you have added. So the good thing here is that you can start small and grow as your demands and data volume demands increase. The database instance storage for RDS is available in 3 types. We have general purpose, provisioned IOPS, and magnetic. So RDS general purpose is suitable for a broad range of workloads. It has a baseline performance of 3 IOPS per gigabyte you have provisioned, and it can burst all the way up to 3,000, and this can be done for an extended period of time. Generally, small to medium workloads use general purpose SSDs. Provisioned IOPS is an SSD-backed storage option designed to deliver fast, predictable, and consistent performance. when you choose provisioned IOPS, you are actually specifying your requirement for the IOPS. And what RDS will do at the back end is it will provision the IOPS rate for the lifetime of that database instance. Provisioned IOPS are ideal if you have transaction-heavy and IO-intensive applications that you want to run, usually production databases. And we have a third variety called magnetic, which is backed by disks. And it's usually well-suited for workloads with frequent access. Now, one thing to note is these different types of storages have different characteristics and performance benefits. So it's really important that you take a closer look at them and design or choose the storage that makes most sense to you. And you can change this at a later time if you feel that you need additional IOPS or if you need to scale back. Yet another desirable feature of or requested of a database is high availability. RDS provides high availability and failover through what we call our multi-AZ deployments. When you choose multi-AZ deployments, RDS automatically provisions a standby replica in a different availability zone. Now, to give you a quick recap, AWS infrastructure consists of regions and availability zones. Regions are really geographic locations where we have these data centers. And availability zones are a cluster of data centers within those regions. So when you choose RDS, you can deploy your database in a multi-AZ fashion, allowing you to fail over to a standby in case you have a planned or an unplanned outage. So the changes that are made to your primary database are synchronously replicated to the standby, and when really the outage occurs, RDS is actually changing the DNS endpoint for your primary database and pointing it to the standby, giving you that seamless operations with your database without having to intervene or do anything in the case of an outage. So it's an automatic failover without your intervention. There are a variety of reasons why you want to choose read replicas. Maybe you want to scale beyond the IOPS that you have already specified for your database. Maybe you have a business reporting or a data warehousing scenario where you want to direct all your reporting queries to a read replica to relieve the burden on your master database. Maybe you want to recover faster in the event of a disaster, or maybe bring data close to your customers. Whatever the reason may be, read replicas provided by RDS gives you the ability to reduce the pressure on your primary database and help with your read-intensive applications. Some companies require their database backups to be in a completely different region, maybe several hundred or thousands of miles apart. In that case, you can choose to create a snapshot and copy that snapshot to a different region and launch your database in that region. You can even take it to another level and have a warm standby strategy for your disaster recovery running in a different region completely. And snapshots also serve as a base for migration to a different region. So let's talk a little bit about backups. In RDS, automated backups are enabled by default. And when these automated backups are turned on for your database instance, RDS automatically performs a full daily snapshot of your data during a preferred window that you define and captures the transaction logs as they are made to your primary database. When you initiate a point-in-time recovery, transaction logs are applied to the most appropriate daily backup in order to restore your database to the specific time you requested. These backups can be retained to a period of 35 days, although this is configurable, but the maximum is 35 days. In addition to automated backups, you may want to take manual snapshots. And manual snapshots are user-initiated, and they enable you to back up your database instance in a known state as frequently as you wish. And then, when you want to restore to that specific known state, it is simply a matter of going to the console and launching a database from that snapshot. Unlike the automated backups, manual snapshots are persisted until you explicitly delete them. And for durability, they are stored in Amazon S3. So the pricing for RDS is straightforward. Your monthly bill will comprise of two components. It's the number of nodes that you're running times the duration for which your database instances are used, plus the amount of storage you have consumed. And again, there is a free tier available for the first 12 months of your usage, and I highly encourage you to take advantage of the free tier to just give these a try, RDS a try. Here are a select group of customers who are actually using RDS for their production environments. As you can see, there are enterprise customers as well as startup customers who are really using RDS successfully. A good example here is Flipboard. So Flipboard, as you all know, is an online magazine and also a social network aggregator that has millions of users and billions of flips. So they use RDS and its multi-AZ capabilities to store their mission-critical user data. They went from concept to delivering a full product in just 6 months with a handful of employees. Another example is Samsung, who are using RDS to deliver their application and content via RDS and saving over 85% over their on-prem solution. All right, so with that, let's get into NoSQL databases. So many of you are already using NoSQL databases. So to give you a quick primer, NoSQL databases refers to systems that are non-relational in nature, and they are really highly available, scalable, and optimized for high performance. So instead of a relational model, they have an alternate model, such as graphs, document stores, or even key-value pairs. So Amazon DynamoDB is one such NoSQL database, and it's a fully managed service that provides fast and predictable performance with seamless scalability. So with DynamoDB, you really do not have to provision anything. You're simply defining the name of the table and the amount of provisioning that you are requesting for that table. The average server-side latencies for DynamoDB are single-digit milliseconds. And it integrates very well with IAM to offer the security features, which we'll talk about shortly. So diving a little bit deeper into DynamoDB, it supports both document and key-value stores. With DynamoDB, you can create a database table that can store and retrieve any amount of data and serve any level of traffic. You can scale these tables up or scale down without any downtime or performance degradation. Management console for DynamoDB also allows you to monitor the resource utilization of your tables and look at the performance metrics. That'll allow you to make changes to your DynamoDB table and take any actions. In terms of security, you have full fine-grained access control. You can restrict who in your organization can access the tables for the DynamoDB table. And there's absolutely no cost to get started. You only pay for what you consume. The simple act of creating a table does not incur any charges for you. It is only when you start storing data in that table and start issuing reads and writes, that's when you are actually charged. So here are some popular use cases for DynamoDB. Now, as you can see, this is by no means an exhaustive or a complete list, but a good selection of how customers are using DynamoDB for their large-scale processing operations. So for example, in ad tech, DynamoDB is commonly used for serving ads, for tracking IDs, for doing some lookups on user profiles, even for real-time bidding and building recommendation engines on top of DynamoDB. When it comes to IoT, you can track the state of the devices that you're using. You can store the metadata and the readings from your IoT devices, and also make real-time notifications online. When it comes to gaming, DynamoDB allows you to build responsive applications or games, as well as build complex leaderboards. When you are running a website, it is critical that you retrieve the information as fast as you can. And to support that kind of an operation in the gaming world, you need a database like DynamoDB. Even in mobile and web space, you can store user profiles, session details, as well as personalization settings to quickly retrieve them in a real-time fashion. Apart from having a throughput provisioned for you and the fast performance that we have seen with DynamoDB, another appealing feature that customers use DynamoDB for is its rock-solid durability and availability. DynamoDB actually spreads your data and traffic among sufficient number of servers to handle the throughput that you have requested. Every write that you make to a DynamoDB table is stored in a solid-state drive and replicated among multiple availability zones within a region. For reads, it supports strongly consistent as well as eventually consistent reads. When you request a strongly consistent read, the response from DynamoDB will be the most up-to-date information that has happened after all the read operations that have occurred before that. When you request an eventually consistent read, the data or the response that you get from DynamoDB may not be accurate, or I should say, it may be stale, because DynamoDB behind the curtain is actually replicating the data among all the availability zones. And once it completes that operation and you make a read request again, you will get the most up-to-date information. So we talked about DynamoDB being schemaless. So what does it mean? So to understand that, we really need to look underneath the data model for DynamoDB. So DynamoDB stores its data in tables. Each table comprises of items. Think of items as rows in your relational database. Each item is composed of attributes. Now, as you can see from this picture, each item has different number of attributes as well as different types of attributes. So that is what schemaless actually means. It means that each item in your DynamoDB table has a different schema. So when you provision a DynamoDB table, you're actually specifying the amount of reads and writes that you wish to perform against that table. That provisioned throughput is measured in terms of capacity units. So in DynamoDB language, one write capacity unit represents one write per second for items up to 1 kilobyte in size. And one read capacity units represents one strongly consistent read per second or two eventually consistent reads per second for items up to 4 kilobytes in size. So here is a simple architecture with DynamoDB. As you can see, there are multiple clients who are connecting or placing requests which are ending up in the Elastic Load Balancing service. The ELB is actually spreading the traffic among a fleet of EC2 instances on which the business logic resides. And the application or the business logic within that EC2 instance is what is talking to the DynamoDB table in that region. So the pricing for DynamoDB is slightly different from RDS. So your monthly bill will consist of the storage that you have consumed plus the amount of write capacity units and read capacity units that you have defined for that table. So there's a generous free tier for DynamoDB, and this free tier is indefinite. For RDS, we have seen that it's only for 12 months, but for DynamoDB, it's indefinite. And you can also reserve capacity with the DynamoDB table. We have the pricing information and all is listed as in that website that is at the end of the slide, the bottom of the slide. So here is a select group of DynamoDB customers. Redfin uses about DynamoDB for about storing about 5+ billion items. They are using DynamoDB for faster lookups of their selected listings. Yet another customer who is using DynamoDB successfully is SmugMug, which is a photo sharing, hosting and sharing platform. There are millions of SmugMug users and billions of photos and petabytes of storage on DynamoDB. Dropcam, which is a video streaming solution, also reduced their delivery times for video events from 5 to 10 seconds to milliseconds when they switched over to DynamoDB. And there are testimonials and some good case studies on the web page which lists how these customers are actually using. Some of them even have their architectures. So I recommend that you take a look at the DynamoDB page to understand how customers are using the product. All right, so with that, let's get into the third managed service, Amazon Redshift. So Redshift is a relational data warehousing solution, which is a lot faster, a lot cheaper, and a lot simpler to launch and operate in the AWS cloud. It is massively parallel in architecture and scale up to a petabyte scale. It can go all the way up to 2 petabytes. It's fully managed in the sense that backups, patching, all happen automatically or taken care by AWS. And it's available in 2 different platforms, the hard disk variety as well as the solid states. And you can get started with Redshift with as low as $1,000 per terabyte per year. So who actually uses Redshift? It's a lot of traditional enterprises who want to reduce costs by extending their data warehousing projects or solutions into the cloud, or who want to burst into the cloud to get the goodness from the data warehousing at a lower cost. A lot of them are migrating completely from their existing data warehousing systems simply because in enterprises, legacy data warehousings cost millions of dollars. It takes a lot of time to provision them, and they're typically the contracts are also longer. The ease of provisioning and the fact that it's fully managed tremendously improves the DBA productivity in many enterprises. When it comes to companies with big data, they are able to run their workloads about 10 times faster than SQL over Hadoop with Redshift. This is because there is absolutely no programming required. Most of you are already familiar with SQL, so it's simply interacting with Redshift using SQL. And you can use your existing BI tools or even machine learning to develop predictive models with Redshift as the backend. Many SaaS companies are also powering their applications by using Redshift. The pay-as-you-go and grow-as-you-need model, as well as the managed availability and disaster recovery, is appealing for many SaaS customers to empower their applications with some analytics. So let's dive into Redshift's architecture real quick. Redshift comprises of a leader node, which is simply a SQL endpoint. This is the node to which your SQL clients and your BI tools connect to using JDBC or an ODBC connection. A leader node is responsible for storing all the metadata associated with your database objects. It is responsible for generating the query plan and optimizing it, and coordinating that query execution among compute nodes. Compute nodes is where the data actually resides. All the operations that are performed on the compute nodes, such as loading, backups, restores, queries, are all performed in a parallel and distributed fashion. And as we spoke earlier, it's really low cost to get started. You can start at 25 cents per hour, and you can grow up to 2 petabytes compressed with Redshift. We have a dense compute instances, which are backed by SSD, and we have dense storage instances or clusters, which are backed by HDD. So one reason Redshift is an appealing solution to a lot of customers who want to do analytics is because it is really, really fast. It is super fast. And it achieves this fastness because it is dramatically reducing the I/O. And how is it able to reduce the I/O? Well, it's because it uses columnar storage. With columnar storage, you're only reading the columns that you're interested. Unlike a row-based store where you are reading a lot of rows and discarding much of it, in a columnar store, you're only reading the columns that you're interested in, and especially in a warehousing type of situation, you are aggregating over 1 or 2 columns. So it is really easy if you can store your data in a columnar format as opposed to a row format. So that's one reason you have a very less I/O. The second thing is data compression. Columnar format also allows you to compress your data better. And when you load your Redshift cluster today, the copy command automatically compresses the data. So the compression not only improves the performance, but it also results in lowering your cost for storage. So that's another reason why Redshift is faster. It has the concept of zone maps. Zone maps keeps track of the minimum and maximum value of each block of data that you have in Redshift. So with zone maps, Redshift can really skip over some of the blocks that are not relevant when it's actually executing your query. The storage attached to the compute nodes is direct, meaning that there's no, it's not going over the network to get the data. It's absolutely direct attached storage on your compute nodes. And typical databases have a block size of 2 kilobytes to 32 kilobytes. But in Redshift, the data block size is 1 megabyte. This improves the efficiency dramatically because you have faster scans, and faster scans results in quicker query responses. Redshift is fully managed You have continuous and incremental backups. There are multiple copies of your data within the cluster. As you can see, if you have 3 compute nodes, your data is replicated among the 3 in a highly available fashion. You can take snapshots of your Redshift cluster and copy them to a completely different region if you want to launch a Redshift cluster in a different region. And a lesser known feature of Redshift is this streaming restore. Here is what it means. Suppose you took a snapshot of your Redshift cluster and you're trying to restore it. So as soon as you launch the restore operation and the cluster is created and some basic metadata is available, you can start issuing queries, and the data is pulled or streamed from S3 as and when you request for your queries. So this is called the streaming restore feature, and it's very useful in restore scenarios. If a disk fails on your Redshift cluster, Redshift automatically makes use of the copies of the same data available on other drives within that cluster. If a node fails, Redshift detects it and automatically provisions another node in its place so that your operations are seamless and there's no interruption. You can even take, as we have seen earlier, you can even take a copy or a snapshot of your Redshift cluster and take it to a different region for disaster recovery scenarios. All Amazon AWS services are built with security in mind. So Redshift is no different. When you're loading data from S3, your data is encrypted. You can also require SSL to secure data in transit. You can place a Redshift cluster or launch a Redshift cluster in a VPC for maximum control or network isolation. And you can use encryption. You can turn on encryption when you're launching a cluster to secure your data at rest. And you can do this either with an on-premise hardware security model or use AWS's Cloud HSM as well. So the pricing for Redshift is also straightforward. It is the number of nodes that you have in your cluster times the duration for which the nodes are used. One thing to note here is that the leader node is absolutely free, and all your tools, your SQL clients, are connecting to the leader node, so all the leader node comes free with Redshift. Redshift has a huge ecosystem of partners. You have data integration partners, you have business intelligence partners, as well as system integrators. That's because Redshift works with customers' BI tool of choice through Postgres drivers and a JDBC ODBC connection. A number of partners shown here have certified integration with Redshift, meaning they have done testing to validate, build Redshift integration, and make using Redshift easy from a UI perspective. So here are a select group of Redshift customers. NASDAQ Security loads billions of records per trading day to track client activities. They process their trades, their codes, and a lot of other analysis are performed on a Redshift cluster. Pinterest saw a 50 to 100 times speed ups when they moved from a 300 petabyte Hadoop cluster to Redshift. Nokia also saw a 50% reduction in cost when they started using Redshift. All these use cases are, again, in our web page and offer great insights into how they are leveraging or taking advantage of the features to not only improve their performance, but also to reduce costs. All right, the last managed service for the day, Amazon ElastiCache. So ElastiCache is a service that makes it real easy to deploy a caching solution in the cloud. Caching dramatically improves the performance of your web applications by allowing you to retrieve the information from a fully managed memory systems instead of a slow disk-based databases. ElastiCache is protocol compliant with 2 open source caching engines, memcached and Redis. It when it has 0 administration. What it means is Amazon ElastiCache automatically detects and replaces failed nodes, reducing the overhead associated with self-managed infrastructures. Imagine you running a caching solution by yourself. You have to think about your nodes crashing. You have to think about failover. All those are taken care of automatically when you use ElastiCache. And from a security perspective, you can run ElastiCache in a virtual private cloud, giving you complete control over network access for your clusters. So what are some of the popular use cases for ElastiCache? So given that caching is primarily for improving the performance of your read-intensive applications, they are an ideal choice to serve as a caching layer or sitting between your application and database. Customers are also increasingly using caches for their ephemeral key value data. That means they have data that they don't want to persist. Maybe it's just a session data that they don't want to persist, or some counters that they want to just maintain for the amount of time that it's used. These are all good use cases for ElastiCache. Even in high-performance application patterns, such as maintaining leaderboards. Now, leaderboards are computationally complex. And the reason is there are concurrent users who are trying to get a rapid response from your website. And it is much efficient and easier to retrieve that information or provide that experience by retrieving the data from a cache as opposed to making a round trip to your database, because it significantly improves the user experience for the gamers who are trying to play their game and have fun and get the quick response. They're also used for session management and distributed counters, which are increasingly becoming popular in many of these high-performance applications. So we talked about ElastiCache supporting 2 different engines, memcached and Redis. What are the differences between them, and when should you use what? Now, again, if you look up answers online, you will see that there are a lot of flame wars going on between Redis versus memcached. It's next only to VI versus Emacs, by the way. So the answer is really in the salient features of each of this engine. Memcached is a very simple caching solution. It is fully managed. It has multi-threaded embedded in it. And one of the features when you use memcached with ElastiCache is that the clients that are connecting to your cluster, ElastiCache cluster, really do not have to worry about connecting to additional nodes that are introduced into the cluster. It automatically knows, the client program automatically knows what nodes exist in your cluster. Redis, on the other hand, is much more sophisticated in the sense that it is single-threaded and it has strong support for advanced data types, such as lists and sorted sets and things like that. And those are very helpful when you're trying to build these event counters or distributed counters. With memcached, you have no persistence, meaning that if a node crashes, the data is lost. But with Redis, you can have persistence, and you can also create read replicas and have failover with a Redis engine. So these are some of the things that you want to look at when you're considering Memcache-D versus Redis. So here is a simple application architecture that you can build with ElastiCache. So again, you have multiple clients making requests, and those requests are ending up on your ELB, or the load balancing service, which is actually distributing all those requests among many EC2 instances. And the EC2 instance is actually trying to get that information first from the cache. It's going to look in the cache first. If it has a cache miss, it'll go to your database, fetch the same data from the database, populate your cache, and return the response to the end user. So here is how ElastiCache billing works. So you have a set number of nodes, and again, it's multiplied by the duration for which the nodes are used. That will constitute your monthly bill. And like the other 3 services that we have seen, it has a free tier for the first 12 months, and you can find more about it on the website listed at the bottom of the screen. So we have many customers using ElastiCache very efficiently. Expedia, for example, uses a 400-node ElastiCache cluster to serve the content or the user experience, and they use ElastiCache actually to store their data for test and experience data for their customers. So they are actually using this big cluster to provide immediate results to the audience or their customers. Dealflix reduced their latency by over 80% after using ElastiCache. And there are other customers like Riot Games who are using ElastiCache for their popular League of Legends game, one of the most played PC games available. So to sum up, there are many, many benefits of using AWS managed database services. By relieving you of all the provisioning, the patching, the installation, the backups, and all the tasks related to the infrastructure, and providing a really easy mechanism to scale while paying for only what you consume, AWS managed database services offer a lot of flexibility to focus your attention on things that matter most to your business, such as your application optimization or improving the user experience for your application. And it's just not that. AWS services are built in a service-oriented fashion, which means that many of these services integrate with each other seamlessly. A lot of times, and in fact, in the earlier slides, you have seen how we have leveraged multiple services to build or put together a solution. So with these managed services, you can use other AWS services to build a complete solution. And I really encourage you all to go use these services, build your real fast applications on the AWS cloud, and show your logo in our talks next time. So before I conclude, I think I still have a few minutes to take your questions. So if you have any questions, I'll be happy to answer them now. Yes? Sure. So the question really is, what does it mean, or what does it cost to run your own database in EC2 versus running with RDS? So the answer to that is simply monthly calculator. So we have something called a simply monthly calculator. If you just type AWS simply monthly calculator, it'll take you to that page. And you can plug in the instance size that you're interested in for EC2. And once you put in that, include your price for licensing as well. And then compare that with the RDS service using the same tool. it'll give you a difference, and then you can have a clear picture of what the cost structure looks like for each of these options. Yes? So we do not move your data. When you have data in a particular region, you explicitly have to initiate a move to a different region. A lot of companies have data jurisdiction laws that prevent data from moving from one region to another. So all the snapshotting backups that I talked about earlier, you can take those snapshots, but you have to initiate the move to a different region. We won't do it for you. So the read replicas are within the availability zone for MySQL, PostgreSQL, and MariaDB. You have cross-region replicas available for MySQL and MariaDB at this time. So only 2 engines support that. Yes, so there are some limitations and constraints that you have to think about when you are moving the data from one region to another. Yeah. Go ahead. Yeah, so it's hourly basis. So you pay by the hour, and even if you use for 30 minutes, you're actually paying for the entire hour.
Right. So, but licensing, Amazon, that's what we call full licensing.
Right. So there are a couple of options. There's a bring your own licensing model as well as licensing from Amazon. You can consider which one works best for you and use that appropriately.
Yeah, so this caching thing, how is the cache will be refreshed?
Fantastic question. So you have lazy loading, and we also allow write-through, as well as you can set up TTLs to expire your cache. And then whatever makes sense to your application, you can choose either of these 3 modes. Yes?
Is there any RDS service today? It mentions that you can scale up on demand, but like with the Oracle one, you have to bounce the instance. Or is there any that will allow you, RDSs that allow you to scale online? Maybe Elastic Online?
I don't know the answer to that. I'll have to look up. So, each database engine has a certain set of restrictions on how you can scale and what downtime, if there is, or availability impact you will have is listed for each database engine separately. I'll have to look into that. Yeah. Yes, go ahead, please.
The maximum storage capacity on one of the slides was shown as for RDS it was 64 terabytes, and for Oracle it was 6 terabytes.
Yes, so for Aurora, it is 64 terabytes. Aurora is a database engine that we have built based on MySQL. It's based on MySQL. With the other RDS engines, you have up to 6 terabytes, except MS SQL Server, which is 4 terabytes. So that's the maximum that you can have.
That's the maximum you can have on AWS. That's not the limitation of those vendors' technology.
Yeah, it's using RDS service. Any other questions? Fantastic. Thank you for being here today, and please remember to complete your evaluations. Thank you.